Hello everyone. I hope my voice is clear to you. And There is some noise today, like a program is going on just near my room. So it it can be a bit problematic. So, but I don't want to shift the class because of that. Okay, so this is 12th week, and this is basically regarding the course. This is the last class. We will have one more class, uh, basically, so that we can revise whatsoever we have done till now in this course, and that will happen on Thursday. So this is the week 12th of Foundation of our software. Um, Okay, so I'm TA Kamna Mishra from the School of Mathematical and Statistical Sciences, IIT Mandi, and the course is instructed by Professor Salab, who is from Department of Mathematics and Statistics, also IIT Kanpur. Okay, so these are the usual links. Okay, so topics we are going to cover in this class are basically these topics. So, if you may remember, in the last class, we have just started a bit of plotting. Um, so, we have just started some plots, like basically how we can make some um, histogram. Where do we use histogram instead of bar plots? Now we will see subdivided bar plots. So we have seen that in the last class, what we have seen is that one, let's say, one thing is if you have kind of only one variable. Mm, okay, so if you go to a market, then on different days, uh, the sales can be different. Okay, now if you have that factor, uh, let's say let's say if you have that factor, let's say in 30 days you have, let's say we say that we have 30 days, okay, per month. So it is not 30 exactly, but let's say we are taking a window of 30 days, and we are seeing what is the factor, basically what happens. Or what we can do is that we can do kind of monthly sale. So let's say we have total 12 months, okay. And what happens is that in some months you will have very high sale, and in some months you will have very low sales, okay. So till now what we have done is that that let's say in let's say we have something like that. Let's say winter, summer, and then all the other months, okay, all the other months, okay. So what happens usually, uh, uh, now let's say I have winter says like this, okay, summer says like this, and other, because all the other months I have taken, it is like this, okay. Or in general, let's say if you are saying just according to weather, so it can be less also. So just take it easy. Okay. So now we only have information about sales in weather. Okay. But what will happen if you want to see that which kind of sale? Like it is not always that okay my sales are high, but which kind of sales are high, that is also important to know. So that company can produce the like this type of clothing, if it is, let's say, a clothes store, so company can make produce that kind of clothing which is important for that weather. So what will happen in winters, if you will see, you will have very high sale for winter clothing which are heavy clothes, and then you will have very less, let's say you have some sale for regular wear, and then you will have very less sale for summer clothes. That's how we think. Okay, that for summer clothes it will be very less. Now if you go to summer, then nobody wants to in general buy, and if you go to even market, then there will not be jackets and all, right? So that time the winter clothing it's very less, and let's say the regular wear whatsoever we wear, let's say without the jacket or something like that, like tops and all, it is normal, and summer clothing will be very high. Whereas if you go to other, so let's say the season is changing, so some person can buy the winter clothing, some person can buy this uh, regular wear, and then you will have some uh, regular wear. So you can see that now there is a difference in winter, summer, and at the end, it is like for all other weathers. So now if I want the bar plot like this, which is divided like this, let's say three parts, then what will I do, what can I do? So that is we can do by subdivided bar plot, and now we have much clear idea what is going on. So now a person will know, okay, my winter clothing sale is high. Jackets are like I need to produce more jackets, more coats, more woolen clothes. Okay, in that way. Okay. So for that, what we need to do is that all we need to do is that we need to give this data, right? This 3 by 3 data I need to give. Okay. So So I'm just putting it as a, firstly I'm gonna do this, although there is no variables, but in case if we will need this some part, then it's okay. So let's say clothing store. Okay, so I'm just saving it as CS. So we have the matrix. Okay, and row is 3 and core is 3 and the data. Okay, so what we are going to do firstly, let's say we will always like since we are going to deal with the matrix, we are just going to put a number, right? So let's say it is already in the units with 1000. So let us say there is 58 units. Then the general will be the 32, and for summer it is very less, so let's say 9. Okay, and for summer the winters will be very less, so yeah, even okay, and say 40, and the main, because we are used to basically buy so much clothing in summers rather than in winters. Okay, So let us say 89. And in the last one, it is basically for others. So we will have some common area for all. So let us say 18, 26, and 35. Okay, so let us say this is our data, and I am saying by row as true. Okay, so this is CS. So you can see first one is for winter, second one is for uh, summer, and the third one is basically for the normal weather. Okay, so now if I will make bar plot CS. Okay, so I mean we can just do this is false, then we can just write. Okay, so now you can see for the winter we have winter clothing very high, and then for this this weather it is low, and this one is more low. Now what we need to do is that, because by looking at this we will not understand anything, uh, like some, I mean we know what we have plotted, but other person will not be able to understand anything. Let me just show it there only. Okay, so what we need to do is that we need to firstly put what is the name of uh, this weathers. Okay, so these are named as this. So let us name it like this: winter, summer, other. Okay. Uh, Now the X lab represents uh, seasons, and the Y lab uh, represents clothing. Let's say number of clothing. Okay. Uh, okay. And the color I want to give is that we can give the separate color. So let's say I'm giving it light blue, blue, dark. Okay, these are three colors I want to give. So now you can see in winter, uh, in summer, and in other seasons. So here if I will add this length, then you can also see that basically in winter we mostly have the woolen clothing very high than the regular one, and in the summer we basically have much more of lightweight, or we do not want the heavy clothes so that it will be uh, easier, right? So this is regarding the bar plot. Okay. Okay. Now the pie chart. So this is basically uh, your subdivided bar plot. So you can make different kind of bar plots. You can also make, let's say, there is one more example, that if you are going to a mall, then you can compare two malls, and let's say you have the shopping of grocery and clothing, and then there is other. So that also you can see, if you, let's say, have a project or something like that, then you can compare these two, and then there are a lot of examples you can uh, have based on this. Okay. Okay, so next we will move to the pie diagram. So pie diagram is basically, you divided some parts, that okay, this much of part is basically coming in this, let's say 70% is this, 30% is this, or if you divide it into much more, so 50% is this, 60% is this. So basically, you will have, let's say, like pie, if you will make the pie chart of this 58, 30 to 14, then it is basically that pie chart you will see in winter it is most, and then in some mostly is this part, and then this part, and then this part. Okay. uh, okay, so okay, so for pie chart, let us take a example. So basically, uh, we have a lot of example where we can divide. So let's say it is regarding the clothing, again, and you want to buy some clothes from Amazon, Flipkart, and what you will have, basically, let's say you will have a thousands of rating of one customer. So in that, you can easily make a pie chart, because you will have, let's say, 1, 2, 3, 4, 5. So we have done this before, I think, in some class. But let me see. Uh, so Okay, so I don't know where it is. So let us just quickly make a data vector, and let's say I'm just saving it as RT as rating, and so we are just going to put randomly some three, four, five. Okay, so far it's 26. So let us say 30. Okay, so let us say we have some 30 people. Now we have seen this previously also. If I will just write it like this, then it will just come like this, okay, which is of no sense. So what we will do is that we will make a table, and based on its frequency we will make it. Okay, so now you can see that the 5 mostly rating is 4 and 5, and 1 to 3 is very less, so you can basically afford it, right? So basically if you want to buy this, then you can. Okay, uh, and if you go to like this, okay, so sorry, let's see. Okay, so here then it is coming as 1 2 3. So basically 1 is 58, 2 is 32, and this. So from that also, like by putting some, like let's say label and all, then you can make it more better. Okay, fine. So there are a lot of ways then you can use this by also. So if in this, if I want to change the color, I can give color, and in this you can see there are 5 colors, so I need to give 5 colors. So let's give uh, and one more. So let's see. Okay, so this way you can give uh, in the main, you can give review rating. So basically you can see now 4 is okay. So now you can see that we have this uh, review rating, and we can see what is the rating differently. So now the next part is that sometimes what we have is that we basically have some plots which we want at one place. Okay, so if I have two three plots. mm, Okay, so now you can see that okay in this one is this, in this third one is maximum, this one is maximum. But if you may remember that bar plot, we have all the plots here. Okay, we have stacked everything. But if you have, let's say, different kind of plot, different plots, and you want to see all in one, like these three, okay, and you want to see all in one place, okay, because that will be very tough to uh, get it understand like what is happening in which place, so you need to flip it again and again. So for that, what we will do is that we take uh, basically uh, that row and how many rows we need. Okay, okay, so if I'm giving 3 1, then you can see it is so big and it is coming like this. uh, So if I am giving 1 3, so now you can see that the first one is for winter, the second one is for summer, and the last one is for other, where all are almost equal. Okay, okay. So if I will put this, okay, so in this there's I don't know, 7. Okay, so this was regarding the uh, pie chart. Okay. Now, what will happen if I will run this? It will only come in one third part of it, because I have given it this and then I have not written like this. So after running this, you need to write it like this, that again come as 1 1. So now it will come as 1 1. Otherwise, all the other plots will come in this 1 3 part. Okay. Okay. So next we will see the histogram. Okay. Okay. So in the last class also we have seen what is the difference exactly between the bar plot and histogram. So in histogram, what we'll have, it is basically for the continuous data. And when we have a lot of data and we do not have, let's say, a same exact numbers of data. So in review, you know that variable is basically the categorical. Okay, so you have 1 2 3 4 5. Or let's say in winter clothing, we have it ourselves given this is 58 32 etc. So but if you do not have it like this, then what you need to do is that you need to take the histogram, because mm if you will have, let's say, 1.1 or 2.3 or 3.7, something like that values, then it will not come in any of it. And even the table will count it, this frequency and this frequency, its frequency and its frequency separately. It will not count it as one. So basically, for the continuous data, we are going to use the histogram plot rather than the bar plot. Okay. So now there are a lot of continuous variables we see in daily life. So basically, if you take a class, then if you have 60 students, let's say, then their numbers, like some can have exact same number, but otherwise, let's say the marks is 100, then there are a lot of possibility that if someone have 80, then other person can have 81. So basically, you do not want a plot in which you will have one, two, like frequency of what is the marks, one, two, and then up to 100. So that will be very long. So what it will do, it will just divide it into 100 parts. Okay. So let's say I'm just saving it as NS, the number of student, numbers of basically student, not number of students. So let us say that it is of 100 marks. So we can just randomly put some numbers. Okay, so till now it is 30. So let us make 60. Okay. Mm, okay, 55, just 5 more. Okay, so we have this. Now, if I make this bar plot of table of NS, so you can see, okay, we remove this firstly. Then you can see, okay, in this there are, let's say, 4 5 students, but otherwise it is not very understanding, like you don't know what is basically plots. So for that we use the histogram. Now, if histogram you will see, you can see basically from 20 to 100. It has divided all into 10. Okay, so 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 80, 90, and then 90 to 100. So you can see that there are very less people who have marks less than 30. Okay, so there is only two people basically. If you move then from 20 to 40, so basically 10 and 2, so basically there are only 12 people who has scored less than 40. And if you go to 40 to 80, so maximum people like on an average have scored from 60 to 70. If we take the mean of ns, then also you can see that it is 64.5. So on an average you can see that 60 to 70 most of the people have are coming in this. Okay, so this is basically that when you need to use histogram, when you need to use this. Okay, now this is basically the simple one, and then what we can do is that we can add like it is not ns, it is not ns, so we can just basically give in main uh, what is sorry, not in main, it is here. Okay, so the main is basically histogram of marks of student. Okay, then in X lab we can write sorry, exactly just marks. Okay, and in Y lab is basically number of student, that how many students have this marks, right? So Y lab will be now the color also we can give. So color we can give as red, let's say. Okay, so now you can see it is basically the marks, it is number of students, and it is the histogram of marks of student. Okay, the next is that uh, it is basically very too much like filled kind of thing. So if I will write density as 2, okay, then it will just come like this. Okay, so if I will write density as 8, so it will just make the lines. Now you can see the lines are in this direction, so we can basically change its angle also. So if I will write angle as let's say 90, so you can see it is coming like this. If I will just change it as 120, so it will just come in the opposite direction, like it was here and then it is just there. Okay, so like then you can make a lot of changes according to what you want. Okay, so this whatsoever we have done till now, it was regarding the when variable. However, let's say in this bar plot, we have basically seen two variables. The first is season, and the second one is type of clothing. Okay, so we have seen two, but then we have tried to make all in one plot. Okay, so this is also some kind of bivariate when we do subdivision of plots. Okay, but proper bivariate plot, next we will see how we can make the bivariate plot and trivariate plot. Okay, so the thing why do we need basically bivariate and trivariate plotting is that there are a lot of variables, a lot of times when one variable is depending on the other variable, right? So sometimes it may happen that one variable is basically very different from other, but sometimes it will happen that one variable is depending or uh, on other variable, or let's say it is basically uh, good. So, mm, what we can do is that by making this bivariate plot, we can understand its relation. Now, how we can understand its relation? So, basically, we can make the scatter plot. Uh, Okay, so if you can have the data, so basically you will never have the data like this, right? You will never have a data like this, that when this happens, this happens. In real life, it does not happen. In real life, you will uh, have something like that. You can have something like that. Okay, but overall, you know that the direction of data is this. Okay, so if the direction of data is this, that when one is increasing, so let's say it is like right now it is 2, now it is 4. So here also it is 2, then it is some 3 or 4 or 5, whatsoever it is. Okay. But both are increasing in same direction. It is not that if one is increasing. Uh, Even here you can see that if you see these two, okay, this 1 and 2 line, then what will happen for 1, it is basically, if you compare 1 and 2, then you will think that it is kind of decreasing. Okay, that uh, let's say this is uh, 1, and then y is 3, whereas it is 2 comma 2. Okay, so you can think that when x is increasing, the y is decreasing, so it is basically the negative. But that is why we can't judge by single point, we need to judge by all the points. Okay, uh, so just want to remove this. Okay, this. Okay, so you can't see this just by looking at one point, that you have looked at this point and this point. So that is why you need to look at basically the whole data. So whole data, if you will see in this direction, then you can see that there is a positive dependence in between them. Now if you will have the similar plot, uh, let's say, okay, you can have sometimes like this also. Then, but overall in general, let's say this one is some kind of outlier or something like that, then you can see that it is negative correlation. Okay. Mm. Then it may happen that you will have basically points all over this. Then you can say it like this, that there is almost nil correlation, or then there is correlation with the p value, that whether the correlation is significant or not. So the correlation comes with a p value to show whether it is significant or not, right? So that also matters. Now if you will, like, let's say now positive also, there will be not always like correlation of 0, -1 and 1. You have basically a range, that -1 to 1 it will lie. Okay, now if it is basically, let's say, minus 0.8 and minus 0.2, then this is much more correlated than this one. It does not matter whether it is a negative or positive. If you have some kind of relation, then it will show. but the thing is that it will only have um, it basically only covers this the linear relationship between these. Okay, so let us take some two variables. uh, okay, so we can have some two variables, so which changes along with. So we already have, let's say, this number of student. So what do you think is one of the sorry, marks of, let me save it as ms because it is marks. So what do you think is one variable which affects the mass marks of a student? Like there can be a lot of factors, that how much he studies, how much he had let's say marks in midterm, that also matters. So most of the time if someone have good marks in midterm, there is high chance they will have good marks in end term also. Whereas for very less number of people, that also happens, that you have some like, let's say, good marks in this in basically, let's say less marks in midterm, but you have gained much more marks in this end term. So let me save it as just okay. And firstly, since it is going to be of 100 marks, so I'm just going to do that. uh, Okay, so some are very less. So now, based on this, we will make some kind of uh, checks. Okay, okay. So then now it is this. Mm, okay, so these are for 20. So now if I will make some plot, so now you can see that it is not exactly the correlated one. Okay, so there are some here exceptions that uh, like let's say this one, that uh, in midterm it is very low but in end term it is very high. Okay, so there can be some exceptions. Now here also you can see that in, okay, basically it is all out of 100, so in midterm it is almost 40 or 41, but in end term also that person has got only 40 or something like that. So that person was supposed to get some 80 plus marks because it was the 40 plus previously, but now there is some exception. But overall, if you will see that there is some kind of positive correlation, right? uh, so if okay, so before making different kind of plots, let us just do this score. Okay, so here you can see there are different type of correlation way. Now there is score dot test, so that will also let you know whether it is basically the correlation is good or not along with the p value, so that you will also understand that uh, that whether it is significant or not. Okay, now there are three types. You can see there is Pearson correlation, there is Kendall, and then there is Spearman correlation. Okay, so you can also define a method here. Let's say I'm defining the Pearson. Okay, so here you can see, what you can see is that the p value is very less, but the correlation is very high. uh, if I will do this candor, so here also you can see the p value is very less, and the correlation is very high. If you do not want this, then you can just do this, and you can see that the correlation also changes in Kendall, in Pearson. Okay, so there is almost 5.5 to zero point 0.6 correlation in between these two factors. Okay, now in this there are a lot of ways what we can do. We can write type is equal to L. So you can see that it is really not making sense because there are anyways very much variable. And there is S. So that is also, that is basically for the connecting one, but it is not very good at this. Then there is B. So B also connects. So that is good when you have the basically I kind of line plot, then it will look much better. If you have O, okay. So that is basically O, and B is basically you are going to include this B and then there is this H. So H is basically going to make the points, all the points. So it depends on your work, but mostly we just make this scatter plot. Okay, like this. Okay, so now again in this, what we can do is that rather than this mmms, what we can do is that we can write this x lab uh, midterm marks y lab and term marks you can have main. So in main, okay. So whatsoever color you will give, then it will come like this. So you can have this midterm, end term marks, then the plot, etc. And then you can have this kind of plot that you can understand directly. Okay. So this was regarding uh, this bivariate plot. Now there is one more way. Uh, okay, we will see. There is a smooth plot. Okay, we will see that. Okay. Now the next one is that we can make the pair plot. So the pair plot will give you uh, this opposite also, that this one is basically in this it is you can see you have one plot like this, and then this one is similar to this, that is this side and then ms is this side, and in this there is just it is just kind of the flip. So you will have the core you will see that these two are the variable ms. So when we will see that basically right now it is not needed because one correlation plot is enough, but when we go to three variable or four variable, then we see how one variable is connected to second and then third and then fourth. So that time it is much more useful to have that kind of plot. Okay, so okay, yeah. So now we will see, just if we will make, you can see that it is basically you can see this is the curve of scatter dot smooth. So it basically makes a line smoothly according to your data, and then it will just make, we can just make this line this scatter dot smooth. So that also you can see is kind of going in the positive direction. This is kind of the positive, and with the correlation value which we have seen here, that also you can see the correlation is positive just by the values. I mean, this can also be seen that it is the positive one. Okay, now in this scatter dot smooth again, what we can do is that we can make it basically a bit colorful and all. So color we can give any color, let's say pink. Uh, and then this LWD is basically if I'm writing 2, okay. uh, if I'm writing 4, you can see it is because of width. So line width is LWT and LTY is for the style. So right now if I will just stick 1, you can see same plot. If I will do 2, you can see this plot. If I will do 3, then it is this plot. uh, if I will make 4, then you can see some dot and then this. So this is basically used to make this one is for different styles and this one is for the width of this line. So that is also we can use, we can do the changes too. Okay, the next is basically the 3D plot. So Okay, so now we have till now we have done just 2D, that okay, that what is the marks in midterm, what is the marks in end term, and uh, at the end what we have based on midterm and end term marks, we have basically the total percentage, so we can have some assignment also, and then midterm and end term and etc etc, and based on that we give some uh, total percentage. Okay, so let's say I'm just saving it as percentage of marks. Okay, uh, okay, so what I'm going to do is just firstly I'm just going to do this. So I will have a bit understanding that what can it be a little bit. Okay. So okay, what I can do is that I can write mm plus ms minus 50. So pm is basically I will have some this kind of percentage. Okay, so let us make a vector of percentage they have got at final. Okay, so okay, so till now it is basically the 20, and then we can have some uh, that will be very less, but anyways. Okay, so I will say 20, 22, 7. Okay, so we'll just we have till now 49 and okay. Mm, okay, perfect. So now we have midterm marks, end term marks, and then total percentage. Okay, so now what will happen if I make the scatter plot 3D? Okay, scatter plot 3D, and I will write ms pm, uh, and then I can give some kind of angle. Okay, okay, so scatter plot 3D, it cannot see. Uh, okay, okay, so now you can see. Okay, so here you can see what is happening. Okay, what we can also see, let's say I can just see for first 10 people. Okay, so now you can see that when I'm looking at just 10 people, I can basically not see what is happening. I mean, there are some here, but if I will just remove this and look for overall, then you can see that here these are all positive, right? This is all positive. That okay, when one is increasing, second is increasing, and third is also increasing. So that is kind of the plot. You can see that all are increasing at one go. Okay. So now this is regarding the 3D plot and all. Now there are a lot of functions you can have. So basically, you can have contour plots. What we can make to define sometimes, let's say, a distribution, bivariate distribution that we can do. Some like basically we can do some perspective plots also. Based on that, some contour plots we can do, and like a lot of that. So let us just make one plot like this. So what we need to give is that if in that kind of scenario, that let's say your x and y. So in bivariate, what do we give? We give the x and y, and we say that x and y is following some kind of distribution. So let's say bivariate normal distribution. So it will make a contour plot of bivariate distribution. Okay. So, similar like that, what we can do is that we can just make, let's say x is some sequence of minus 5 to 5, and we can put its length, how much we need to, what is the length kind of basically we want to find out. So let's say it is the 50, and y is also the same, or basically you need to have the same length of x and y. So you can either have the same or you can have the different one, and then we can define some function of xy, which we have seen earlier also, how we can define a function, 3D function. Okay, so for that, what do we need to do? We need to define the function of xy. uh, okay, So let us define some function. So what we can have is that, let's say, some x square plus y cube. Okay. Okay. And in that x cube y cube also we can further take, let's say r is x cube and y cube, or we can just return this r. Okay, but okay, let us see what it makes. Okay, so now this is the function, and I want z to be outer x y. So you can see the z has got these values. uh, Okay, so you can see now this is very weird kind of plot. So these are some things we can give to change. You can see its direction has been changed. The pi, if I will give, then it has flipped like this. So you can see it is for x square plus y cube. If I will do x square plus y square, what you can see is that it is basically uh, okay, so it is basically x square is y square basically is a sphere. Okay, so this is kind of like above, from the above side, if you will see, this is kind of a sphere. Okay, then we can make a lot of changes in that. We can take its square root, we can make its cosine function, let's say, uh, or let us just take the square root of this r. And since the values of this, if you will see, it is very high, so we can divide it also by 10. So now you can see this has been changed after taking the square root. Okay, now in this, what you can do is that expand zero point 0.5. Okay, so you can see now it is much more clear. uh, then you can basically give any color to it. So if I will just give this, then you can see this is filled with this color. Okay, so after that you can basically try to do this. um, okay, so after doing this 30, you can see that you can see this x and y and the z direction. And then what we can do is that we can basically write whatsoever we have written till now here. Let's say the x lab, y lab, etc. So in this x lab, y lab, and z lab is basically x, y, and z also only. So that is, we do not need to define. Uh, in the z way, you can write the function also. Okay. So this was all regarding the plots. And basically the last of this is was covering uh, how to write a program, so that we will see after doing the examples. Okay, so firstly we will do this examples, like the first question is basically uh, okay, so first question is basically, if the number of patients taking a particular medicine uh, is given by this, which is n is equal to 12, 15, 20, this and this, then which r command will return the bar plot of this data. Okay, so now it is basically when you have all the same numbers, then both of it will give you uh, okay, let me just close this one time. Okay, so if you will make this and the below one, you will have both, basically in both you will have the bar plot, and you can see that this one is your bar plot and this one is this. Okay, so we need to give like C. Okay, so now you can see that it is not making that difference that you are able to understand. Okay, so firstly that there is no C written in the second one, there is only C written in the first one, so that is going to be the correct answer. The next is that suppose you roll a die 20 times and with the sum of numbers of upper faces recorded, which our function is used to create histogram of absolute frequency of the sums. Okay, so basically in that last we don't know, so we do not have exact same number, so it will be histogram of sum of the data. Okay, the next is that if you have given the family income x and the food expenditure is y data, then which r command generates a scatter plot of income versus this. Okay, so we have just seen if you have L, then it will make some kind of line plot. If you have both, then it will make some uh, like both. B is basically for both B and L, O and L. If you have S, then it will make some stepwise. So you should not be like confused with S with the scatter plot. The S is basically shows something different. So the correct option will be the C one. Okay. The next is which R command will generate a pie chart with the title sale in shops based on this vector sale. Okay. So we will have the pie and then table is not needed because it is already 1 2 3. So we will have pie says, and then you may remember that we do not write the title, we write main. Okay, so this title is wrong, this is also title. In these two you can see that we do not have any vector to define, so we will just write pie sales. Okay, and the last question is basically, uh, so this one is basically the function. Okay, so we will see how we can write this function. So what is written, that is square root of sum of cubes of three numbers. Okay, so what do we have? Sum of cubes of three numbers. So you need to always start from the last. Okay, always start from the last. So firstly, okay, three numbers, then cubes of three numbers. So firstly, then sum of cubes. So sum of cubes of three numbers, not cube of sum of three numbers. Okay, so you will have x cube, y cube plus z cube, first thing. Then is square root of this, so it's square root. This is our function. Now how we can define it? uh you can write as square root, cube root, whatsoever you want outside. Okay, now it is basically you have Okay, so here firstly you need to give the bracket. If you will not, if you have not given the bracket, it will not work like this. Okay, in here it is also, I don't know exactly, so you can give right like this actually, cube root. Okay, and then the first one is that x cube plus y cube plus z cube and square root of f1, and then print f2, that also you can use. And in the last, here you can see it is written x, so this one is wrong. You cannot do the sum firstly, so that is you need to take care of this. So you will always start from the last. So last we have started that cubes of three numbers, so it is cubes of three numbers, then sum. So we have given the sum in between, and then square root of all this, so we will give the square root of all this. So that was the basic idea. And in the last uh, uh, basically in the last class of this course, in the last chapter kind of, so we have seen how we can define different functions, and then how we can save it, and then how we can find it basically. So there can be a lot of functions you can define, and let me show you one of the examples. So you can define, let's say, a function like this. Okay, you can see this variable, you will put it, and then you will find the value. Okay, so this is the way, like it can be as large as you want to be. Like you can see here there is an a1, a2, b1, b2, t1, t2, so it can be a lot of like you can have as much of variables as you need in that. Okay. mm, so okay. So let us see how you can define, like these are the functions which we have defined directly. Like this is the function which we have defined directly, but how we can define a function, two, three functions with condition that it also happens sometimes that if you have this, then the function will behave like this, otherwise the function will behave like this. So if we want some kind of function like this, then we can define it like this. So let's say you have a function of x and y, and um, if let's say x greater than 0 and sorry, greater and y greater than 0. Let's say you have this function, then what do we want to do is that, uh, so here we have x and y, and these are negative, positive both. Uh, so what do we want to do? If these are both positive, then we want to just okay. So we want to make some exponential of uh, let's say this function is square root of this x square plus y cube. Uh, Let me write it like this so that it will. Okay. And then whole of it divided by 100, let's say. Okay. And I want the exponential of it if it is like this. Else, else if x equal to 0 and y equal to 0, then if let's say when both the points are 0, then I am saying that give it function 1. And else, like whatsoever the other one, so other one will be when x less than 0 and y less than 0, then I'm going to define a function uh, let's say similar, but here, because if y cube, that will be very negative, then it will be problematic. So I'm just saying that now define it as y square. Okay, so now my function is defined. uh, so if I will write g of, let's say, minus 5 comma minus 5, you can say it is like this, uh, minus 5 and 5. So now you can see, when x is greater, let's say x is less than 0 but y is greater than 0, then also it is coming in this condition, right? Because whatsoever is the condition, so basically, uh, if you will look at this function, I have defined it, uh, I have defined it like this. Basically, let's say 4 quadrant. So I have said that if x and y both are greater than 0, then define it like this. Otherwise, it is 1. Or otherwise, these are all will come in the else part. Otherwise, you can define it much more better way, like else if, and then you can see x greater than 0 and y less than 0, x less than 0, y less than 0, and then x less than 0 and y less than 0. So you can define the multiple form of this function also. Okay. Okay. uh, okay. Okay, so this was regarding the one point. Now, what we already have x, y with ourselves. So if I will just write z1 as a 0, and for I in length x. Okay, so I in basically 1 to length x, I can write. Okay, and then I want to define my function z1I as this g of, okay, g of xi comma yi. So yi is basically, y is this, so y1 is minus 5, so something like that we can. Okay, so now if I will write z1, you can see this is my final result. So I can make this. Now again we will have this 3D plot. So I can make a scatter plot 3D, let's say. So I have x, y, z. Okay, sorry, its length are differing. It is 50, x is 50. The length is same. I don't know what's okay. Sorry, not z. It is z1. Okay. So you can see this is the kind of plot it had make. Okay. So as we have seen in this. Okay. So it was also this kind of plot. So basically the sphere, if you take half of that sphere and if you just rotate it, then you can see this kind of plot. Okay. So this is one of the way you can define. So whatsoever function you want to define, it is very simple. You need to give the variable name. Then if your function changes with the variable, then you need to say, okay, when the variable is changing in this, then write like this. If it is changing in this form, Or let's say sometimes it may happen that you know that when it is 0, then if you will put function like this, then it will not be well defined. I mean, it can go to infinity or something like that. So to not get that kind of problem, we just make it like this. uh, so we define the functions like this, and then you can see basically, if you want the function value, let's say at g5 5, okay, so you can see it is this. And if you will see z1, you can see this one is this value at 5 5, okay. So by using the for loop, you can basically have your function value at each and every point of x and y. And you can define like for 3 variables, 4 variable, 5 variables, that does not matter, okay. Okay, so if anyone have any questions, they can ask. Okay, so what we will do is that we will just quickly go through everything. I'm removing this so that it will be much clear. So what we have done, so I'm just removing all of the variables. So firstly, what we have done is that we have seen how we can make subdivided bar plots. To make subdivided bar plots, what we have done is that we have taken a matrix and we have defined our matrix in that form. Then we have this first and second and third column. So this is plotted like first, second, and third column. If you have defined, like, let's say your matrix in separate different form, let's say I have given by row as false, if you have given by row as true, or even for false I do not need to write. So if you have given by row as true, then you all you need to do is that transpose of cs. So t of cs if you will do, then also you will get this. So it is coming with the legend, so we have also added the legend also here. Then we have seen how we can make some pie chart, okay, and then we have seen how we can get, let's say, three pie chart I'm making for, let's say, winter, summer, and other seasons. Then we can get all in one. Then we have seen that if you are doing this 1 2 3, then you need to do 1 3 1 1 also, okay. And then at the ms one, okay, so let me write this for 3 1 also, because what will happen, so some people may not remember that you need to give row only, you do not need to give the column, okay. So we are not going to make, uh, no, not for continuous data, okay, not basically not good for continuous data, right? Whereas for continuous data we make the histogram. Then we have seen that we can include, till now we have done univariate plot, then this will be bivariate plot, so we have included the midterm marks also. So then we have seen this correlation, then scatter, and then we have seen we can make some scatter plot 3D, okay, and then we can make some function to make this kind of plots. Then we have seen how we can define the function basically on our one, okay. So this was more or less regarding today's class. Okay, so the next class is on Thursday. That will be the revision class. Okay, so thank you.